Hi all, so this is guided practice 5. I'm trying again, see if we can get some volume going here. And this is our applied problems when we're solving linear equations. So we start out by identifying our variables. So if you take a look here at question number 1, before the final exam, the student has test scores of 72, 83, 65, 73, and 62. If the final exam counts as 1/3 of the final grade, what score must the student receive in order to have a final average of 76? So I always look at this last statement to decide what my variable should be. So what score must the student receive? And they're referencing the final exam score. So X is going to be my final exam score. And then they want me to average this as a weighted average. So we take the weight times the score and add those up, and that has to be our final average of 76. So the first thing we're going to do over here is go ahead and find the average of these numbers. So 72 plus 83 plus 65 plus 73 plus 62, and I'm dividing by how many I have, so divided by 5. And this comes out to be 71, okay? So then this is my exam average. And it says that the final grade is the final exam counts as 1/3 of the grade. So the rest, the remaining 2/3, we're going to assume is this exam average. So we're going to take 1/3 of our final exam score. So 1/3 times X. We're going to add to that 2/3 of our exam average, which is the 71. And that we want to be a 76. Okay. So from here, we're just solving this equation. So we're going to go ahead and clear our denominators. So I'm going to multiply everything by 3. So when I distribute this to the first, and I'll write the small one out. So 3 times 1/3 X plus 3 times 2/3 of 71 equals 3 times 76. I don't do this often, but I thought I should do that just to show you what's happening. So then when we cancel, these 3's will cancel out, and I'm just left with X. These 3's will cancel out, and I'm left with 2 times 71, or 142. And over here, it's 3 times 76. And 3 times 76 is, let me find it real quick. $228. And then to solve for our X, we're going to subtract the 142 from both sides. And when we do that, we get 86. So they need an 86 on the final exam to get that average. Wait a second. 76 times 3 minus 142. Yeah, 86. So we need an 86 on the final to get the overall grade of 76. On to number 2, a couple does not wish to spend more than $70 for dinner at a restaurant. If a sales tax of 8% is added to the bill and they plan to tip 15% after the tax has been added, what is the most they can spend for the meal? So right here, what is the most they can spend for the meal? So my X is going to be cost of the meal. And then we're going to take that X and we're going to add an 8% sales tax. And we do that by multiplying by 1.08, right? 0.08 is the 8% sales tax plus the original amount gives us 1.08, or 108% of the cost of the meal, so times X. Okay, and actually don't actually need these parentheses, so let's take those out for a second. It's a little bit cleaner without them. Okay. Now, we're then going to take that amount right there, and we're going to take 15% of that. So I'm going to take 15% of 1.08 times X. And we're going to do the same thing and multiply it, only this time it's 0.15 added to our 1. So we're taking 0.15 times 1.08 times X. And we want that to be 70 to find our max amount. Okay, so I can rearrange that multiplication and make it 1.15 times 1.08. And when I multiply those two together, I get 1.242. And that's multiplying my X. And then to solve for my X, I'm just going to go ahead and divide by that decimal on both sides. And that will give me the cost of the meal. So if I take 70 divided by the 1.242, I get $56.36. So if they can keep the cost of their meal under that amount, once you add the tip and everything, it will be no more than $70. Next, 600 people attended the premiere of a motion picture. Adult tickets cost $9 and children were admitted for $6. If the box office receipts totaled $4,800, how many children attended the premiere? So we're going to start for here. How many children attended the premiere? So X is going to be the number of children attending. Okay. Now I need to know how many adults in terms of the children. So adults, let's see, we have total of 600 people. If X of those people are children, then the rest are going to be adults. So adults are going to be the 600 minus the number of children. Okay. And then we want to talk about the ticket prices. So ticket prices, adults cost $9, children cost $6. So we're going to take the number of adults. So the 600 minus the number minus children is my number of adults, and I'm going to multiply that many people by $9 for their ticket, and I'm going to multiply the number of children, which is our C, times $6, and that will be the total cost of their tickets. And all together, when I add all that up, it's got to be $4,800. And now I can go ahead and solve for C. So 9 times 6 is going to be 5,400 minus 9C plus 6C is 4,800. Then I'm going to go ahead and combine my like terms. So the things with C's are like terms, and that's going to give me 5,400 minus 3C is 4,800. Let's go ahead and subtract the 5,400 from both sides. And that is going to give me, oh, I'm running out of space, negative, I'm going to go over here, negative 3C. And when I subtract that, that's going to give me negative 600. And let's divide both sides by negative 3 to get our C by itself. And that's going to give me 200. So the number of children is 200. And then the number of adults would then be 400 to make a total of 600 people. Now, I think in the first video, I set this up by letting adults plus children equal 600. And then we just subtracted the C over, right? And then we put the two equations together, which you can do, or you can just say, okay, well, if I know how many children, then the adults have to be 600 minus those number of children. Okay, so a couple of options. All right, on to the last one for this. A salesperson purchased an automobile that was advertised as averaging 27 miles per gallon in the city and 38 miles per gallon on the highway. A recent sales trip that covered 1,762 miles required 51 gallons of gas. Assuming that the advertising mileage estimates were correct, how many miles were driven in the city? So my X is my number of city miles. And then my non-city miles, or I guess there's my highway miles, right? Let's use that. That's a little more straightforward. Well, I know that all total I have to be 1,762, and then I'll just subtract off how many city miles I had, which is my X. So my highway miles are the 1,762 minus however many were in the city, so minus my X. Then what we're going to do is to figure out how many miles, how many gallons we would talk about. Well, the number of gallons you used is going to be something that we divide by, right? So if you went 1,000 miles and you got 10 miles per gallon, you would divide that 1,000 by 10 to figure out how many gallons. So we're going to use that here, even though our numbers are not as nice. So I'm going to take the number of miles for the city, which is X, and I'm going to divide by that gas mileage for that one. So 27 miles per gallon. Plus the expression for highway miles, which is the 1,762 minus X. And I'm going to divide by its gas mileage, which was the 38. And all total, that's going to give me 51 gallons of gasoline. From here, what we want to do is we want to clear our denominators. It's going to make our numbers big, but that's fine. So I'm going to multiply by 27 and by 38. Okay. When I do that, the 27s cancel in this first term right here, and I'm left with 38x. In the second one, the 38 cancels, and I'm left with 27x times whatever was already there. So times the 1762 minus x. And then I have to take 51 times 27 times 38, which, let's see, is 52,326. So now I'm going to distribute here on the left. So I keep this first one, the 38x. Then I'm taking 1762 times 27 to get 47,574. Distribute again, that's minus 27x. Then I can take my two like terms and combine those two. So that's going to give me 11x plus the 47,574 is the 52,326. Now I'm running out of room, so I'm going to add a page. There we go. Now let's go ahead and subtract off the 47,574. And that will leave me with 11x equals and that leaves me with 4752. And we can go ahead and divide by our 11. Get 432 gallons. Okay. So key thing is we take our number of miles divided by the rate of miles per gallon, and that'll give us the number of gallons.